say that this is right here would be py. Okay? That so far so good, I guess. So remember that you will also divide this vector into two components, one right here and one down the slope. Okay, so the weight in the x direction is going to be 382.6 times. That's what you need to be careful with here. You know that this angle here is the same angle as here, as this angle right here. So that's going to be your x component is going to be basically the 8 divided by 17 component. Okay. So I'm pretty much flying over this because you guys have seen this before. Okay. So I'm not doing a full explanation. So this is basically 180.0. So I'm going to say 180 newtons. This is a round up of, in this case, I'm rounding up to 4 significant figures, even though you only see 3. Okay, and Wy would be 382.6 times 15 divided by 17. Okay. So that's the weight. That's the weight component. Okay. The weight component will be 382.6 times 15 divided by 17, and that is 337.6. Yeah. So. Okay. All right. So we got those two. Now, we also need to know px and py. Right? So px would be, in this particular case, the component px is going to be the longest one. It's going to be p times 15 divided by 17. Okay. And py is going to be p times 8 divided by 17. Okay, this is 17. Okay. And then, of course, you need to consider the friction force, which is if the impending motion is happening down the plane, right? So impending motion is down the plane, the friction force will oppose impending motion, right? So friction force is going to be in this direction, right? So this is your friction force, or F max. So it's right here. Okay. And then you have, of course, the normal force, which is going to be applied in this direction. That's the normal force. Okay. Another thing you know is that you know that F max is equal to mu times the normal force. So that's going to be basically mu times the normal force. Now, if you do the sum of forces in the y direction being this tilted or inclined coordinate system, right? You have a number of forces here. The forces are, first one that I see is the normal force, which goes up. Then you have the downward force, the component of the weight, which is what we call Wy, which is basically 337.6. Then you have yet another component, which is going to be the component of P, which is Px. So it's going to Py, sorry, not Px. It's Py But we know what py is. Py is a function of p, right? So instead of writing py, I'm going to write uh,
हाँ भाई यार वो छूट गया
I'm
वो
going to write
वो पहले
p
कर लो वेब की तो कर लूँगा तुम लोग
times
के पहले
8
अच्छा
divided by 17. Okay?
वो भाई भाई क्वेश्चन देख तो लो वैसे तो
And
इसमें से आंसर
basically, those are all the
फिर मैं करूँगा
forces
ये वाला क्योंकि एक दो में मेरे 50 हैं
that
बस
we have in the y direction. The normal force N,
हाँ भाई
337, which is a component of the weight, and this force P
मैंने भाई स्टार्ट
y.
करवाओ उससे
Okay, so that should be equal to
करवा
0.
लो भाई
And that's
करवा
one
लो
of
उससे
my
क्या
equations. If you do the sum of forces in x, then you will get the following.
बस यार भाई वो
You
सुबह
have
रन करना है
dx,
क्योंकि तुम्हारे तो
which
बीच में
is
क्योंकि आ गए थे
p
ना बढ़िया वो वाले
times
में मेरे 50 आए हुए हैं बस
15 divided by 17.
मुझे
You
ये
have
वाला कोई
the
बढ़िया करवा दियो यार
friction force,
बढ़िया
which is
नंबर
a
मिल जाएंगे
negative
क्विज में
force, and it's equal to 0.6
हाँ भाई ले लेना यार मुझे रन करना है क्विज पे
n, right? So that's your friction force,
वेब वाली करेंगे यार
which is actually in the negative direction. You do have a positive component of the weight, which is 180 plus 180 Newton. And you have the component of P, which is pulling down, which is going to be also positive, which is px. So that's P times 15 divided by 17. Okay. I already included that, so that's, I'm repeating myself. Okay. So let's see, we got the component of P, we got 0.6 N, which is the friction force, which is in the negative direction, and we got the weight, which is 180. Okay? And that should be equal to 0. Okay. So as you can see, you have two equations with two unknowns. Okay? So if you have two equations with two unknowns, you can solve this system of equations to find the normal force, which is really not what you're looking for, but the value of P, which is what you are looking for. So there's a number of ways of doing that. Perhaps you can substitute or isolate P from this equation and put it as a function of the normal force, and then write an equation as function of a normal force and solve, or the other way around, which is probably more convenient, which is to replace n in this equation with the correct value. So let's do it that way, okay? So you could say that from, if this is 1 and this is 2, you can say that from 1, you can say that n is actually equal to 337.6 minus 8 divided by 17p. Okay? You can take that and then basically sub 1 into 2. And then you got basically 15 divided by 17 p minus 0.6, which is multiplying n, but now we know that n is 337.6 minus 8 divided by 17 p. Right? That's n. That's my new n. Plus 180. And that should be equal to 0. Okay. And now we have we have to multiply all this. Excuse me. Okay, so it's 0.6 times 337.6 is actually 202.56. So let's just write this again. 1517 is P minus 202.6 plus point, let's see, this is 0.6 times 8 divided by 17. That's 4.8. So I'm going to divide by 17. I'm going to do away with the fraction now. And that's actually 0.2824. P plus 180 is equal to 0. Okay, so I'm going to add up now the two numbers. So I'm going to say that P is equal to 202.6 minus 180. That's actually 22.6, so it's going to be 22. Basically 1517. So 15 divided by 17 plus 0.2824. It's actually 116.4. I used one more additional. I used 5. Perhaps I should use only 4 just to see what type of error we get. So now I'm going to divide this. 22.6 and 1 divided by this is 19. Newton. Okay. So that's basically what you need to do to find the value of P. So is it a lengthy procedure? More or less. I was trying to do it slowly so you'll see how to
Okay, perfect. Thank you. I got somehow 22.14. I don't know how, but like that's fine.
You got 22. Well, it depends because you may have.
Yes. No, my data was different than the first time, right?
Yeah.
But right now I got 18.72, so it's almost like a 4 newtons difference. So I don't know what's the deal, but that's fine for me right now. I just want to learn like what happened.
Ah, okay. Okay, take a look. Perhaps you can, because there are so many calculations, there could be some errors.
I did every calculations with you right now, so I'm gonna figure it out, like what's wrong when I did first. Okay, thank you.
Okay.